Hey guys, welcome to the channel Unshackling Sudokus and Puzzles. Today's video will be on a remote clone Sudoku created by Kumaresan. This Sudoku video is being made on some of our viewers' requests who wanted to know how this variant is to be solved. The thing about this Sudoku variant is that it is present in the ongoing Sudoku Grand Prix series at World Puzzle Federation. The round is being authored by authors from France and Hungary, and it is already ongoing at the World Puzzle Federation website. I will add the link to the contest page in the description of the video. Please do try to give out the contest. I can vouch for their quality. The quality will be immaculate. It will be so nice to solve the Sudokus, and you can try them out at your leisure. So this Sudoku is the highest pointer. This Sudoku variant is the highest pointer in the contest, and we were looking for a good practice Sudoku, and Kumaresan came to our rescue. We asked him for a Sudoku and he made the Sudoku in very short notice. So we are extremely thankful to him for that. And if you want to try this Sudoku out yourself, check out the solving link given in the description of the video. And let us move on to the rules now. Classic rules apply, and then lines in a cell that mark that in those two directions both digits are the same at a distance of n, where n is the value of the cell. Not all possible lines are given. Okay, rules are simple. So for example, if you have, let's say, let me go to Sudoku mode, Sudoku normal, Sudoku center. Okay, my screen little bit. Yes. So for example, if you have, let's say, a value of 3 here in the line. So all these cells are the cells with lines. So you have some right angle shapes, right? So in all those cells, suppose if you have a value of, say, n, let's say 3 for example, so then you need to travel 3 steps in each of the directions. So those would be this cell and this cell. So which means that both of these cells would be equal. So for example, they may be 2. So this is applicable for each and every line. You travel the exact same number of steps as the digit in that line, and when you land at that cell, both the values should be equal in the direction pointed by the lines. So these are the rules. With that, we'll start solving the Sudoku. It seems to be a very interesting one. So the thing about this Sudoku type is that always look for lines which are closer to the edges of the grid, or which are closer to the boundaries of the grid, or in short, which have less number of cells to travel. So for example, if you look at this cell, it can take only 1 or 2, because 3 or anything more you can't travel. It will go outside the grid. So which means that this cell is going to be 1 or 2, and it obviously cannot be a 1, because then both these cells has to be equal. So which means this would have to be a 2, and both of these cells become equal. So let us look for cells of this sort. So for example, this is also limited in value. It can take only 1 or 2. And this cell, so it can only take 1, 2 or 3, can't be anything else, and you have a 3 here, which means that this has to be 1 or 2, and that gives us a pair, a 1, 2 pair. Let us maybe look at this cell. It can take a total of 1 to 6 values, from 1 to 6, out of which 3, 4 and 6 are eliminated, right? So which means that this would be 1, 2 and 5, can't be anything else. So 1 is possible, and 2 is also possible, and 3, 4, 5. 5 is also possible, right? So we can't eliminate anything for now. So let us maybe look at this cell. So it can also take any value from 1 to 6, out of which 2, 5 and 6 are eliminated. So this would be 1, 3 and 4. Okay. Is there any digit that we can place by classic? Okay, you have a 4 here and you have a 4 here. So which means that this digit has to be a 4. So that was an easy classic step. And we also know that one more small thing about this Sudoku is that a 9 can never be present on the line, because you just don't have enough cells to travel 9 steps in any direction. So the maximum number of steps that can be traveled in any direction is 4, 5, 6, 7, 8. So the maximum value in these lines, no matter where they are present, would be 8. So which means that in row 9, 9 has to be present in one of these cells. It can't be anywhere else. And we know that both of these cells must be equal for this cell. So which means this is not a 9, and it has to be 1, 3 or 4, right? Because this value is equal to this value, and 4 is here, so which means this is not 4, so this is 1 and 3. Okay, so we have a very sharp deduction here, guys. Really sharp deductions. Suppose if you have a 1 here, let's say you have a 1 in this cell, then both of these cells must be equal, and you can remove the 1 from here, so this becomes 2 or 5, and which means that this would be 2 or 5, but both 2 and 5 are ruled out, right? So you cannot have a 1 here, as that would not give any possible digit in this cell. So which means that we can eliminate the 1 from this cell, right? So this is a 3. This has to be a 3, and which means both of these cells must be equal. Okay, so which means both of these cells must be equal for this clue. So this is also a 3. Okay. So how do we continue here? Okay, 4 must be in one of these cells, right? Because of classic, you can place the 4 in any of these cells. Now let us try to look at the values of this cell, because it can take a maximum of 5, out of which 1, 2 and 3 are eliminated. So which means that this cell can only be 4 or 5. So if it is a 4, 1, 2, 3, 4, the fourth cell from this direction will also be 3, right? But this is an 8, 1, 2, 3, 4. So which means that this is not a 4, so that becomes 5. And the fifth cell from this direction is 1 or 2, which means that this cell also has to be 1 or 2. And both of these would have to be equal. We just need to remember that. Seems to be a very interesting Sudoku, guys. And which means that the 5 in box 5 has to go in one of these cells, classic. So now if you look at any of the remaining lines, they can take quite a few values. So let us try to start placing at them, because there doesn't seem to be anything simple here. Okay, 3 can be placed here using classic, and 5 is in one of these cells, classic again, and 9 is in one of these cells, and 5 has to be in one of these cells, again a classic. So I can eliminate the 5 from this cell, right? Because that's fast. 1, 2, 3, 4 and 5. You would have 9 as the fifth cell, but we know that 1, 2, 3, 4 and 5. 9 can never be on the lines. So which means that this cell is not a 5. So 5 has to be in one of these cells. Let us try to maybe place some digits in here. This can take a maximum of 6, 1, 2, 3, 4, 5 and 6, out of which 3, 5 and 6 are ruled out. So this must be 1, 2 or 4. 2 is possible, 1 is also possible, and 1, 2, 3, 4. 1, 2, 3, 4. Even 4 is also possible, because 6 can go here. So I think we need to write some more digits. So now let us try to look at lines which can take maybe a maximum of 6. So because rest of the cells we have marked which are limited in value, maybe look at this cell. 1, 2, 3, 4, 5, 6. So which means that this cannot be 4 or 5. So this has to be 1, 2, 3 and 6. And if it is a 2, then both of these cells must be 5, but you have a given 4 there. So this is not a 2, so this is 1, 3 and 6. And let us maybe look at this cell maybe. Okay, it can take lots of values. No, it can take a maximum of 6, right? So 1, 2, 3, 4, 5, 6. Out of which 5 is immediately ruled out. And can it be 4? Yeah, 4 is possible. Okay, lots of values are possible here. And we missed this line. So it is very limited in value. It can take only maximum of 3. So let us mark that. So this is 1, 2 and 3. Okay. So this is 3. Both of these cells would be 8. And I don't see any problem with that. Okay. And by classic, we can also place a 5 in one of these cells, right? Corner pencil mark. So we know that both of these cells must be equal for this clue. So let us try placing some digits there. This can't be 2, 3 and 5. And it also cannot be 4, 8 and 9. So which means that 2, 3, 5, 4, 8, 9. So which means this can only be 1, 6 or 7. And this would also be 1, 6 or 7. And that gives a 5 here, right? 5 is eliminated from this cell. So which means that this would be a 5. And even 6 can be eliminated from here. So this is 1 or a 7 and this is a 1 or a 7. And now we know that both of these cells must be equal for this clue, right? For the phi clue, both of these cells must be equal. So in these kind of Sudokus, if you use some form of notation to indicate that some cells take the same values, it would be really helpful. So we just need to remember that both of these cells are equal here. While solving, you may use some notation, and both of these cells are equal. Okay. So let us try writing some candidates here. Maybe 1, 2, 3, 4, 5, 6. So it cannot be 3 or 4. So this has to be 1, 2, 5 and 6. Cannot be anything else. So it obviously cannot be a 2 because both of these cells would have to be 3, but 3 is ruled out. So this is 1, 5 and 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Everything is possible there. So maybe let us write some possibilities here. It can take a maximum of 8, right? Out of which 3, 4 and 5 are ruled out. So which means that this would be 1, 2, 6, 7, 8. And even 1 is ruled out, guys, because then both of these cells have to be equal. Not possible. And 8 is ruled out because you can have a maximum of 7 steps. So 8 is also ruled out. So 2, 6 or 7 are the possibilities. Okay. So we know that you have 1 or 2 here. So at least one of the digits, I mean exactly one of the digits. Yeah, one of the digits in these two cells would have to be here, right? So I was thinking that 3 can be placed here, but actually it need not be the 3 which is pointed at by this cell. Okay. Okay, if you look at this cell, it is very limited in value. I think 2, 3, 5, 1 and 8 and even 9 is ruled out. So which means that this would have to be 4, 6 and 7. There is no other value that this cell can possibly take. And I think you can rule out the 6 from here, right? So it's a very sharp deduction to see if you have a 6 here, then this cannot be 1 or 2, because if you have a 1 here, this would have to be a 6 and that would lead to a clash. And if you have a 2 here, then this cell would have to be a 6 and again you have a contradiction. So which means that this cell cannot be a 6, this would have to be 4 or a 7. A really sharp reduction. So do we need to write some more possibilities here? I'm not really certain. Maybe let us write some possibilities here. It cannot be 1, 2, 4, 5 and 8. So both of these digits must be must take the value 3, 6, 7 or 9. And I'm certain that 9 cannot be pointed at by this cell if 9 is present in these two cells, because you have a 9 here. So certainly 9 cannot be pointed at by this cell. Okay. So if this is a 2, then both of these cells become equal in value and both of these cells would have to take a 7. And that gives a 1 here and a 1 here and a 1 here. Okay. Wow, this is a very sharp reduction, guys. Very sharp reduction. It's really tough to see. Let me just look at it once again to see if that is correct. Okay, that gives a 1 here, 1 here. Both of these cells become equal. 3 is ruled out, 6 is ruled out, 9 is ruled out, and 7 is also ruled out, guys. A very tough one to see. So you cannot have a 2 here. So let's say you have a 2 in this cell. Then this becomes 7 and this becomes 7, right? You don't have any other option because 4 is not possible. So which means that this cell would be a 1. And now both of these cells become equal. So this would also be 3, 6, 7 and 9. And 3 and 6 are immediately ruled out, which means this would be 7 and 9. And 9 is also ruled out. So this would have to be a 7, which means that this cell would have to be a 7. But you already have the 7 here. A very tough one to see, guys. So 2 can be ruled out from that cell, right? It requires a lot of look ahead. So I think you can expect these sort of deductions in the actual contest. Not really certain because this is the highest pointer in the contest. So which means you can eliminate the 2 from here. So this becomes 1 and that becomes a 2. Which means that this both of these cells are equal and that would have to be 3, 6, 7. That would have to be 3, 6 and 7. And both of these cells are equal, so which means this is a 6 and 6 is ruled out from here and 6 is also ruled out from here. Okay, so 2 is ruled out from here, classic. This is 1, 3, 4 and 6. Okay, this cell is now 4, 7 or 9. Nothing else can go there. And 1, 6, 8, 3 and 4 and you have a 2, 5 here. So you can mark a pair. This becomes 2, 5 and this becomes 7, 9. And the rest of the cells in that column must be 1, 6 and 8. Okay, maybe let us try to write some more possibilities. If you look at this cell, it cannot be a 1 because then both of these cells would be equal, and 2 is also ruled out, 3 is also ruled out, 5 is ruled out, so this can only be 4, 6, 7 and 8. Nothing else can be present over there. If it is a 4, then this cell would be a 3, okay, no problem. And if it is a 6, then both of these cells become equal. Okay, this would be 1 or 5 and this would be a 1 and this would be a 1. This would be 3, this would be 3. Okay. Okay, so I can't have a 7 here, guys. 1, 2, 3, 4, 5, 6, 7. Then if you have a 7 here, then this cell 1, 2, 3, 4, 5, 6 and 7. Okay, you can have the 7 there. I was thinking that the 7 is landing here, but actually it's landing here, but 5 is possible here, right? So let us try to write the possibilities here. Maybe 1 is ruled out, 3 is ruled out and can be maximum 7. So 2, 4, 5, 6 and 7, right? 2 is possible. 1, 2, 3, 4, 5 is ruled out because 5 cannot be in any of these cells. So 5 is ruled out from here. So this is 2, 4, 6 and 7. And so we know that both of these cells must be equal. What am I missing here? And for this clue, okay, this should have been marked, guys. So we know that this 5 clue is pointing at 5 cells away and both of those values must be equal. So this is a 2. So which means that this is 4, 6 and 7. And 2 must be in one of these cells. So we have a very sharp reduction here. The moment we mark 2 in one of these cells, we can eliminate the 1 from this cell, right? Because if this cell is a 1, then this becomes a 2. And now for the 1 clue, both of these cells would be equal. And for the 2 clue, both of these cells again would be equal. So which means that both of these cells become same in value. That is not possible. So I can eliminate the 1 from that cell. So this is a 2 or a 4. Ah, superb, guys. 4 can be ruled out from here now. Superb. You keep on chipping away at the Sudoku until you reach the solution, right? So it's tough. 2 was in one of these cells. Now if this cell is a 4, let us think what happens if this cell is a 4. If this is a 4, then both of these cells must be equal, right? 1, 2, 3, 4 and 1, 2, 3, 4. So this becomes 6 in value, and which means that for this cell, this would have to be 1 or 3 because 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5 and 6. You need to have 1 or 3 here, but you can't have 1 or 3 here. It's only 4, 6, 7 or 8, which means that you cannot have a 4 here. That's a lot of look ahead, right? I mean, very sharp reductions you can say. So this is not a 4, this would have to be a 2, which means that this is not a 2, this would have to be a 6 or a 7. Okay. And both of these cells are equal, we have marked that already. So what do we do now? Oh, awesome, guys, awesome. Again, Again, what happens if this cell is a 5? We know that 5 is in one of these cells using classic. So suppose if this cell is a 5, then both of these cells become equal and both of these cells immediately become 7, right? Because 4 and 9 are ruled out, then both of these cells become 7 in value and this becomes 6, and now we have a contradiction between these cells, guys. So when you have 6 here, 1, 2, 3, 4, 5 and 6, and 1, 2, 3, 4, 5 and 6, both of these cells must be equal. That is row 3 column 2 and row 9 column 8 must be equal, but we know that both 3 and 7 get ruled out. So which means that you cannot have a 5 here. Superb, guys. I'm not sure if there is something else better here at this point. So we will use whatever we find here. This seems to be a tough Sudoku. So this is a 5. And I know that now both of these cells must be equal for the 5 clue. So which means that this would be 4, 6, 7 and 8. 1, 2, 3, 4 and 5 and 1, 2, 3, 4 and 5. Oops, I'm sorry, guys. So the fifth cell is having a value of 6 or 7, which means that this would also be 6 or 7, right? Okay. And I can eliminate the 6 now from here because 6 lands here and here, and I know that 5 cannot go here. So this is not a 6. 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5 and 6. So this is not a 6. This has to be 1 or 3, which means that if it is a 1, then this would be 6 or 7, and if it is a 3, then both of these cells would be 2. Okay. Okay, I can rule out the 4 from here, guys. So what happens if you have a 4 here, right? Oops. So if you have a 4 here, then 1, 2, 3, 4, 1, 2, 3, 4. Both of these cells must be equal. That is row 5 column 8 and row 9 column 4. So which means this would be 4, 7, 9. 4 and 9 are ruled out. So this takes a 7. The same contradiction that we obtained when we got using a 5 here. So which means that this cell would have to be a 7 now. Right? And that becomes 6 now. And which means that the 6th cell 4, 5, 6 has to be a 4, 1, 2, 3, 4, 5, 6, but it cannot be a 4. So which means you can rule out the 4 from here. A tough one, guys. So we are eliminating digits one by one, and that gives us a pair. Maybe this is the break-in that we are looking for. So you get a pair here, 6, 7 pair in the row, which means that you cannot have 6, 7 here, and you cannot have a 7 here. And do we get anything? So if you look at row 9 carefully now, so we have got most of the digits that we want, and 1 has to be placed in the row. Obviously 1 cannot go here, both of these can't be equal, so 1 has only one cell left, so 1 goes here, and using classic we get the 9 here because 9 has no other cell in the row, and that removes the 9 from here, and I have a 6 here, so 6 is also removed, so you get a 3, 7 pair, and which means that gives a 4 here, and this, because of this one, you get a 7. And both of these cells now become 6, 8. Classic. And now these two cells must be, this cell must be 4 or 8. Again, you have 6, 7 pair. So you must have 4 or 8 as the candidates. If I have 4, 1, 2, 3, 4, both of these cells must be 3. And if I have 8 here, this becomes 4 and this becomes 4. Okay, both may be possible. Alright. So 7 can be eliminated from here, right? What am I supposed to look at here? Okay, now I can eliminate the 7 from here. So if I have a 7 here, then the 7 cell is 5, then the 7 cell here is 4 or 8. So this cannot be a 7, so this would have to be a 6, and that gives a 7 here. Now the 6 cell is a 7, which means that 6 cell from this direction would be a 7, and which means that this cannot be a 1 because then both would have to be 7. So this is not a 1, sorry. This has to be 3, 4 or 6. And it also cannot be a 6 because 6 lands here and both of these are different. You cannot have 6 here. So this is 3 or 4. Okay, for this clue, you need to have both of these cells equal. So which means you can resolve this 3, 7 pair. And 9 in column 6 has only one cell left, so which means 9 has to go here. Now we are getting some digits thick and fast, guys. So let us see if we can complete this Sudoku now. okay, for this clue, both of these cells must be equal, right? So which means that this would have to be a 7 for the 3 clue, I mean, and that gives a 7 here using classic. I may miss something very apparent here, I'm not really certain though. So you can eliminate the 2 from here because both of these cells can't be equal. So this would be a 1 or a 3. 2 is eliminated. So if I have a 1 here, then both of these cells become 3. Okay, 7 is here, right? So you can place the 6 here immediately. Again, classic. So 6 goes in one of these cells in box 9. 9 goes in one of these cells in row 2. So if I look at row 8, the remaining digits are 1, 4 and 9. And I can eliminate the 4 from here and here. So 4 goes here. So this is not a 4 and that is not a 4. So you get a 1, 9 pair, a useless pair because you can't resolve that. But however, this 4 gives us an 8 here, which means that this would be a 4 and which means that the 8 cell in either direction would have to be a 4. So this becomes 4 and for this clue, the 3 clue has to be, the 4th cell has to be equal in either direction. So 3 goes here. Superb guys. It's very fun to solve, but at the start you have to keep chipping away at the Sudoku, eliminate pencil marks one by one. So it's not an easy variant certainly. 1, 4, 6, 9, 5 and 7. So remaining digits are 2, 3 and 8. And 8 is obviously ruled out from here because you'll step outside the grid. So this is 2 or 3. 2 is possible and even 3 is also possible. And you have the 4 here, right? Which means that this is a 3. And one more small thing that in the Sudoku is that not all possible lines are given. So which means that you may have, for example, there is no line here, right? Which means that, for example, you may have a 6 here. 1, 2, 3 and 4 and 1, 2, 3 and 4. Both digits may be 6. So you are not supposed to use vice versa rule here. It's important to remember that. So 3 here gives a 1 here and both of these cells become equal for this clue. So this is a 3 and that's not a 3 anymore. This is 2 or 8 and you get a 2 here now, classic, that gives 8 and these cells must be 2 and 9. Can you resolve something? So 1, 2, 3, 9, 4, 5, 6, 7 and 8. So this is a 6 and that is a 9 using classic. So these two cells must be 1 and 8 and you have a 3 here, which means that this is a 1 and both of these cells become equal now, both of these cells. So this would be a 6 and that gives a 1, 8 pair and that resolves this 6, 8 pair. And if I look at row 4, the candidates here must be 2 and 5. We haven't yet looked at this cell at all, right? These two clues. So let us try to write something there. 2, 4, 7, 1, 8, 9. So these must be 3, 5 and 6. And using classic, I can eliminate the 3 from these two cells. This is 5 or 6. Okay. I think I can eliminate something there, but I'm going to go with the classic. So 4 is removed from there. So 4 goes here. And this one gives us an 8 and a 1 here, and which resolves this 1, 8 pair. And these 3 cells must be 2, 7 and 8. And this one resolves this 9, 1 pair in row 8. And which means using classic, this must be 1, 6 and 8. And you have 1, 6 here, so which means this would be 8 and this would be a 1, 6 pair. So 1, 3, 4, 6, 5, 8 and 9. So this is a 2, 7. And this is also a 2, 7. The moment I wrote that, I noticed this 2, 7, 9 triplet, so which means you get a 1, 8 pair here. So what do I do now? So the 7th cell in either direction is equal, right? So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this has to be 8 and that resolves this 1, 8 pair, that resolves this 1, 6 pair and that resolves this 6, 5 pair. Superb guys. An excellent practice Sudoku and that too in short notice, like I mentioned earlier. Thank you Kumaresan for this wonderful Sudoku. So you have 2, 8 here. So this is a 7, that's a 2, that's a 7, that's 5 for the column and that resolves this 5, 2 pair and this 7 resolves this 7, 9 pair and 9, 2 pair and this must be 2. And with that we have completed this wonderful practice Sudoku by Kumaresan. Hope you guys got to learn a thing or two about this Sudoku. To summarize, try looking for lines which are near to the boundary, and try to eliminate possibles. Also use notations for digits or cells which contain equal values. That will also help in the solve. So please let us know your thoughts and comment as to how you found the video on the Sudoku. We'll be happy to hear out from you, and please remember to subscribe to the channel and do share the video with your friends and family who may be interested. So I'll see you once again. Take care until then. Bye bye.